Okay. Okay. Once again, my apologies, guys. I got a little stuck in the traffic and I just got home a few minutes back. So the delay, hope you understand. And let's go ahead and get started here today, guys. Okay. So come here. Let's come here. We are in, let's see, that's not us. That's us. Okay. Looks like Katyusha introduced yesterday, guys. We'll go ahead and have a quick round of questions. And let's see, who do we have today? Okay, let's see how I have Advait Nandelli on the top. Let me go ahead and, pardon me, unmute you. Advait, you're on air, buddy.
Yeah. Hello. Can you hear me?
Yeah, go ahead, Advait.
Yeah. I have just completed my master's and I don't have any work experience. Not familiar with something like this. Just related to some of the concepts like big data and just few of them. Some SQL part, that's it. And even not with some Java.
Okay, cool. Not a problem. And you completed master's in what, Advait?
Electrical engineering.
Electrical engineering. Okay, that's not bad.
Yeah.
Okay, so you're cool. You shouldn't worry much. And no, Java is not a must. As I said, not everybody will have Java. It's helpful. You don't need to be an athlete to be a cricket player. Would be my take on that. So that would be my thing. And you've been attending yesterday and day before yesterday sessions, Advait?
No, I have missed those two classes actually. I just went out.
Oh, okay. So I guess I will not be able to ask any questions. Okay, that's cool. So what we'll do is allow me to move ahead here with other folks, and you try to attend 2 or 3 sessions. I'll come back and we'll have a quick review of questions.
Sure.
Okay, great. Thank you. And where is your location, Advait?
I'm actually right now in Texas.
Texas, which city?
Irving.
Oh, nice. Very good. How's Irving today? Warm, cold, or hot?
It's actually really cool. Not that cool, but it's really good. Pleasant weather today.
Oh, I know what that means in US when somebody says it's really good. Huh? That's really a blessing. Yeah. So hopefully you're having fun there. But good, Advait. Thank you, buddy. I'll go ahead and be back here and we'll catch up again. Thank you, Advait.
Yeah.
Okay, guys. So let's move on. Let's see. I have Irfan next. Let me unmute Irfan. Let's see how he's doing. Irfan, you're on there, buddy.
Yes, sir. Hello, sir.
Hey, good. Go ahead, Irfan. Give us
I have completed my master's
in computer science. Very good.
Yeah. My uncle suggested me to take the course of big data.
Excellent.
I have consulted in various technologies.
Okay.
I have a little bit knowledge in C# and ASP.NET.
Wonderful.
And hunting for a job in both the fields.
Very good. Okay, that's cool. That's not a problem. It's you're in computer science and you're already familiar with C# and ASP.NET. You should be able to relate to a lot of concepts here. And where is your location, Irfan?
I am in Louisiana State, Baton Rouge City, sir.
Louisiana. Oh, okay. Louisiana. Okay, that's a fun city, isn't it, buddy? Baton Rouge. Okay, I hope I'm R-O-G. I don't know. Okay, I'll leave it like that. How about that? Cool. Good. How's Baton Rouge today?
Yeah, it's raining very heavily here.
Raining. All right. You better stay home. You're in the right place, sticking to your computer and laptop. And all right. So good, Irfan. Allow me to shoot a few questions here in a friendly way. And okay, first question, medium complex question. What is Hadoop?
The task which we cannot complete on regular databases, we use Hadoop.
Okay, all right. What you cannot do with a car, you can use a lorry or a bus, is what you're saying. Okay, acceptable. But okay, how about this one? See if you can answer this question, Irfan. What is distributed file system mean?
All the computers connected in a cluster. acting as a one computer.
Good. A group of computers acting like a single computer. That's a distributed file system. And that is also Hadoop. As simple as that. Okay, buddy?
Okay, sir.
Okay. Another thing you also, again, a medium complex question. What is the problem that Hadoop solves?
It processes a large data sets.
Very good.
Usually cannot be solved by RDMS or.
Okay, excellent. Or in other words, it's a solution to big data.
Yeah, solution to big data.
That's a short way to remember it. And okay. Slightly tough question in a friendly way, no pressure, Irfan. What does SDR mean?
Split, distribute, and process. Split, distribute, and reduce.
Replicate.
Replicate.
Replicate. Okay, very good. Okay, and okay, a very tough question, Irfan. Okay, again, no pressure. What does data locality mean?
Data locality, whenever we replicate in Hadoop, we usually replicate like 3 times. So in the name node, we store the information of metadata.
Okay, that is the name node. Okay, anything else?
That is, is that data locality actually?
No. Data locality is your data is local and code moves to the place where the data is sitting. In the world of Hadoop, what happens is we load the data. When we load the data starts sitting. That is the only time data moves. If you have, let's say, 100 terabytes of data, we only load it once. After we load it, what we do is we go ahead and write code in HivePick, Java, MapReduce, and things like that. What happens at the time is your code moves to different computers and then it processes it. So that is what we say, data locality. Cool. Okay, great. Very good, Irfan. So I'll wrap it up here. And thank you, buddy. You take care. Cool. Great. So that is Irfan, guys. Some good answers there. So let's move on to today's topics, guys. Okay. So I think it looks like we are here and we'll dig deep into, come here, into Hadoop a bit more. There you go. Okay. So these are some of the topics we'll try to cover today. We'll go into the details of Hadoop, guys. So let me just adjust my screen here and come here. Let me see where my tool is. Can't find it here. Okay. Take shortcut. There you go. Stay snap. Cool. So let's see what we have here, guys. Okay. So here is Hadoop cluster, guys. Okay. Let's try to understand what's a cluster. What's a cluster? Well, before understanding cluster, let's take a look at a rack. What is rack? A physical enclosure where you can plug in multiple servers. In other words, a group of servers is called a rack. Okay. In a rack, all these are these pink and blue boxes are servers, guys. And what happens is there is a switch. What is the switch? The switch is used for connecting. So indirectly, what is happening is there is a wire which is getting plugged in from here to here. There's another wire which is getting plugged in from here to here, and so on for the other things also. All those things are connected via that switch. The switch is called Tor switch, top of the rack. It sits on the top, so that is why it is called Tor or top of the rack switch, guys. Okay. Then we have what is called central switch. A Tor switch connects all the servers in a single node. A central switch is connecting multiple Tor switches. So when we are able to collect multiple switches, these servers can communicate with each other. That is what the intention is. Okay. In other words, that is central switch. That is Tor switch, guys, top of rack switch. And what do we have? A group of racks. This group of racks is referred as a cluster. Okay, guys. So that is one thing. And then within the cluster, we have something called name node, job tracker, and things like that. We'll try to understand that in a second, guys. Okay. So that is a cluster, as simple as that. Everybody with me, guys? Everybody okay with this slide? Pardon me. Cool, great. So let's come back here. Let's move on and let's see what we have. Here is how the specifications of these servers look like, guys, in a production environment. So what do you have? Well, you have something called name node. This is a master. What is a master? We will Let's see. On switch, please. Okay. So switch. Let me see if I can do an undo here. Can do it. Okay. So switch is, nothing but, something which is used for connecting these nodes or servers, Srijan, as simple as that. And that is called Tor switch, TOR, top of the rack, and that is called central switch. That is pretty much, what I have. But let me know if you have anything specific more that you want me to explain, Srijan. Okay. Great. All right, guys. So here is the specs of how these servers look like. We have name node. What is name node? I will explain to you that in a second. We also, what is name node? Well, that is something which has very, very high RAM, 64 GB RAM. Just imagine, guys, okay? That's a server, so they generally have some good amount of RAM, 64 GB, 96 GB RAM, and more than that is what they have. There's another server which is referred as secondary name node. And there are some servers which are referred as data nodes. These are called workers. These have generally less amount of RAM, okay? And come back to hard disk, that is 1 terabyte hard drive in that one. About generally these two will have same configurations. They're just a copy of the same thing, guys, okay? Then we have 6 times 2 terabytes. What is that? 12 terabytes of data. We can maintain a single hard disk with 12 terabytes of data, or we can maintain 6 hard drives, each one with 2 terabytes of data. So generally, it is better to maintain multiple hard drives with small amounts of data, guys, okay? What happens is, if we maintain, let's say, imagine, come here, let's do a little bit of cleaning up here. Imagine we maintained only one hard drive, which was 12 terabytes. What can happen? Well, there's a possibility that can fail. Now, if one hard drive fails, what happens? We have 12 terabytes of data which becomes unavailable. But imagine, come here, we have hard drive 1, hard drive 2, hard drive 3, and 4, and so on. Okay, now imagine what is this? Well, imagine like that we have 6 hard drives, each one is 2 terabytes. So, and imagine for the sake of simplicity, this failed. What do we have? We will still have a bunch of other hard drives which are available. Okay, in other words, we have only 2 terabytes of data unavailable. The rest of the 10 terabytes or whatever that is, it has, will still be available, guys, okay? So that is the advantage of maintaining multiple hard drives, something to keep in mind. Come back to processors. Processor, about 8 cores, these are master servers. We'll talk about that. They have generally much higher configuration than the data nodes, guys, okay? And the data nodes, the worker servers, generally have, less spec on the configuration of the processor. And yeah, every box is one physical machine, as simple as that. Data node, name nodes, these are background processors, Srijan. I will just talk about them in a bit. Okay, and so again, process about 2 cores for all the things. I repeat, each of the boxes is a physical machine. This is an expensive physical machine. Okay, and these are inexpensive machines. The orange colors are inexpensive machines, guys. And come back to Ethernet, the expensive machine, they come with redundant. Everything is redundant. In other words, they have 3 Ethernet wires. Generally, it's about 2, guys. We don't really need 3 of them, but a couple of Ethernet wires can be plugged in. The objective is, it's an enterprise class server. If one of the Ethernet wire goes bad, it still has the second one as a backup. So that's why they come with a couple of them. And for the data nodes, again, even though we're saying 3 here, it's only 1. Generally, 1 Ethernet wire is plugged into each of these nodes. And here, we're saying it as 32-bit, guys. This is a correction. In the next slide, I have it corrected. This is actually 64-bit. Okay, 64-bit CentOS. CentOS means it is a version of Linux or a distribution of Linux is what it is. For now, you just think that is Linux for sake of simplicity. Don't confuse yourself, guys, okay? And another point, if we have CentOS here, we generally have the same CentOS in other physical machines also. We have to install the same version of Linux in others ones. You cannot have CentOS here and Red Hat Linux here. Although in the later versions, I think they are trying to fix that one, but generally that is not how it is done. They maintain that uniformity across multiple servers. Okay, so Srinivas, what I'm saying is, if we maintain about the hard disk, only one hard drive with about 12 terabytes, what happens is, if the hard drive fails for some reason, what happens? The entire 12 terabytes of data will become unavailable. Whereas, if in a single physical machine, instead of maintaining one hard drive, you maintain multiple Let's say we maintain 6 times 6 hard drives with 2 terabyte each. And what can happen? Well, imagine one of the hard drive fails. The other 5 hard drives are still working. What does that mean? Only 2 terabytes of data is becoming unavailable. The rest of the 10 terabytes continues to be available. Is that making sense, Srinivas? Is it a virtual or both? It could be virtual or it could be physical also. Generally, in a production environment, it is physical. It's not virtual. For development testing, you can go ahead and virtualize it. Cool? Okay. Okay, guys, here is another look at another spec, or mostly similar specs, but some minor changes here, guys. Okay, so about 64 GB RAM, same. These are the expensive servers. The one in the blues are the expensive servers, and 1 terabyte hard drive. Okay, no change there. Processor 8 cores, no change. Ethernet, but here we've just corrected. 64-bit CentOS, power redundant. There will be 2 power plugs plugged into this enterprise class servers. So if one power plug fails, it has a backup. That's the intention. And these are inexpensive commodity servers. They're much cheaper compared to the enterprise class servers, guys. Okay. And what do they have? Well, again, generally they will have about 1 wire plugged in. We don't really have 2 also here, but multiple hard drives is what they will have. And generally less amount of RAM compared to the enterprise class servers. They can also have more RAM. It doesn't mean they will have only less RAM, but that is what that is. Cool, guys. Everybody okay with this one, guys? With this slide? Cool. Okay, let's move ahead. Now, come back to the architecture of Hadoop, guys. Okay, so let's come here. So imagine, before understanding the architecture of Hadoop, imagine this is an IT company, guys. In this IT company, there are 2 groups. Who are they? One is the project management group. That is one in the blue. And then you have employees group. Okay, these project managers are the people who are monitoring. That's why they're called the masters. And the rest of the employees are the workers. They are working. That's why they're called the workers, guys. Okay, now that is one look at it. And let me see what we have. Okay, now let's go ahead and extend it a little bit more. In this IT company, clean this up. There are 2 departments. What are the 2 departments? Well, we have what is called a hardware department, which is this one. Then we have a software department, which is this one. Who is this guy? This guy, imagine this guy is the hardware project manager, and this guy is the software project manager. Okay, so in the project management groups, we have a couple of managers is what you want to keep in mind. Then imagine each green box is one physical machine. There are a few background processes running. Or in other words, imagine each green box is one cube in your IT company. There are 2 guys sitting in that in each cube. Or let me say, there is each green box is one big cube, in which there are 2 small cubes. In each cube, there is 1 employee sitting. The first employee is data node. Who is he? He's a hardware employee. These guys take care of the hardware. What do? They report to their hardware manager, who's called the name node. Okay, they constantly report. What do we mean by reporting? If you're familiar, generally in the work environment, every Friday, we go ahead and fill up a status report. And we will, that's how, and that status report is constantly being monitored by our project managers and things like that. So that's how we report, guys, okay? So that guy is your hardware employee. This guy is your software employee. What is he? He's task tracker. What does he do? He will report to his project manager. Who's that? That's job tracker. For now, just remember that is the door number of the software project manager. That is the door number of the hardware project manager. Okay, so one more time, guys. We have 2 groups. One is project management group. Another one is worker group. The project managers are called masters. The employees are called workers or slaves. It is a master worker or a master slave architecture. Then the second thing is, we are saying we have a couple of departments. First thing is groups. The second one is department. Okay. The first department is a hardware department with a hardware manager. The second department is a software department with a software manager. In the workers, we have, for sake of simplicity, let's assume that is 1 floor. In each floor, there are a couple of cubes. In the first cube sits a hardware manager. That guy will report to the first guy is a hardware employee. That guy will report to the hardware manager. The second guy is a software employee. That guy reports to the second software manager, guys. Okay, everybody with me so far, guys? Is that making sense? Cool. Okay, I'll try to explain a little bit more. So I'm not done yet, but with this slide, that is what I have. Let's move ahead a little bit and let's see what we have here. Okay, now come back to the hardware department. In the hardware department, the hardware manager's name is that. The hardware employee's name is that. Who's this guy? This guy is called the master. Why are we calling him the master? Because he manages. He manages the employees, his hardware employees. Okay, what is he? He's an expensive guy. He's an enterprise class server, an expensive server. Okay, in other words, he's like a Ferrari car. Or in other words, imagine in your IT company, we are paying very high salary to our project managers for sake of simplicity. That's why we have Ferrari car there. I'm thinking that is Ferrari, guys. I don't know if that is not Ferrari. Please feel free to let me know. And then we have workers or employees. Who are they? Well, they are called the data nodes, and those are cheap servers. Or in other words, that's why we have the taxes shown there. Okay, and what do these data nodes do? What they do is they report to the masters. They fill up their status report and send their status reports. Okay, they're deployed on each machine and provide the actual storage. Okay, so now let's go ahead and do a little bit of cleanup here. And let's say, imagine, come here, and let's select this one. Come here. Let's select blue. We'll plug in a, oops. Come here, come here. We'll plug in a master here. And we'll come here, select this. We'll select this one as a worker, worker 1, worker 2, worker 3, and for sake of simplicity, worker 4. Okay, for sake of simplicity, let's assume this is our laptop. Somewhere, let's go ahead and plug it here. This is our laptop. And what does laptop have? Let's say, for sake of simplicity, let's choose this. It has a file which is again 100 MB. For sake of simplicity, that's a 100 MB file. What is the first step, guys? If you remember, the first step is split, right? So we want to go ahead and load this file into the Hadoop cluster. Let's select this one. Come here. This whole thing is our Hadoop cluster. This group of computers is Hadoop cluster. Now, what we're going to do is we're going to go ahead and take this. We're going to split this. That will be, let's say, for sake of simplicity, that's 64 MB again. And come here. Let's say that is 36 MB. Cool. Okay, now take the 64 MB, save it to one server. Take the 36 MB, save it to another server. This is called distributing. It is distributing, and then it replicates it, guys. Okay, we'll forget about the, or actually, let me go ahead and also replicate it. Come here, select this. So a copy of the replica is created here. A copy of the replica is created here. Similarly, come back here, take the pink, and that's a copy of the replica. It's a copy of the replica for the thing. So this is replication. Now, as this is happening, guys, what is happening? You see this master, this is a project manager. What is he doing? Well, this guy is making a note of it. What is the note he's making? Let's come here. Let's type it here. We'll say, he's saying there is file F1. F1 is split into blocks A, comma, B. A, and let's say comma, B. And block A is sitting in, come here. Let's say server 1. We'll call this as data node 1, 2, 3, and 4. So let's say for sake of simplicity, data node 1, comma, data node 2, comma, data node 3, comma, data node 3, which is our pink things, guys, pink blocks, okay? And then here is B. What is B doing? Let's come here. Let's say, imagine, okay, it is saving data node 2, comma, data node 3, comma, data node 4. Okay, so what is the master doing? Master is managing. What do we mean by managing? He's tracking this file. Where is it split? This is the split information. Then the first two things indicate the distribution information. The next two things indicate the replication information. What is that? That is what the master does. He maintains the metadata of which block is sitting in which server, where it is distributed, where it is replicated. That is what the master does. Where is the actual data? The actual data is getting stored on the worker servers. The worker servers are inexpensive servers. Master servers are your Ferrari cars. Okay, guys? And let me see what else I can add. And as simple as that. Everybody with me, guys? Everybody okay with this slide? Is that making sense? Cool. For now, in the context of this slide, keep that in mind. Let's go ahead further and let's come back here. Let's take another look at this one. Come here. Discard it. Come here. Okay, back to our IT company. So that's our IT company. What do we have? Well, there's our first department. And we'll call this as Department 1. Select this. Increase this. This is our Department 1, guys. Okay. What is this? This is the hardware department. Then come here. This is the software department. Our hardware department, we call it as the HDFS, the distributed file system. Our software department, we call it as the MapReduce, guys. Okay. And why do we call it HDFS? Because the hardware department is just concerned about the storage. It does not do anything. It's just about storage. So what are our hardware employees doing? They're just hardware employees. What do they do in an IT company? They just fix the servers and make sure the hard drives are there and things like that. So that's why we are calling them as a hardware department. They're just maintaining, saving some blocks of data, which is nothing but a part of a file and things like that. And then what happens is, once the servers are set up, what happens in an IT company? Well, we go out and write some programs. Who's that? That is the task tracker. What is task tracker? Each task tracker is like a software developer. Each software developer, what do? They use these servers, and then they will go ahead and do the processing. In other words, the software developers are responsible for the processing, or the MapReduce engine is the processing department. This is the storage department. Everybody with me, guys? Is that making sense? Cool. How about others, guys? Just keep giving me a few. I see Irfan is the only one who's pretty religious here about the acknowledgements. Cool. Thanks, sir. Okay, guys. So that is Hadoop 1.2. This is Hadoop 1.2 architecture. In Hadoop 2.0, our entire IT company has been redesigned. What we will do is our IT company 2.0 or Hadoop to IT company, the redesigned IT company. Oh, sorry about that. I come here. Oh, sorry, 1 second. Sorry about that, guys. Okay. Master is split into 2 blocks. Okay. So let me just back up here for Srujan's benefit, guys. Okay. So what Srujan is saying is master split into 2 blocks. No. Okay. I think I probably lost that one. But let's take it from here. Come here. Take a snap. Discard it. Plug it here. And let's come here. We'll take our file. That's our laptop. From our laptop, imagine we're going back and saving our file, which is 100 MB. So that's our 100 MB file. So the first step is we split the data. So let's go ahead and choose, since we have a green there, let's choose a blue. That's 64 MB, Srujan. And let's go ahead and choose, let's say, how about, oops. That's my little angel probably. Okay, that's the second block. Now that is splitting. We select this. We're going ahead and storing in data node 1. We're going ahead and storing. Who? Not us. It is Hadoop which is doing this. Okay, we don't have to be a mechanical engineer. Hadoop takes care of distributing it. Then it is going ahead and replicating. As it is getting saved and replicated, what is happening? This is making a note. The master is making a note. What is a note he's making? Well, imagine he's a project manager. What do project managers do? Well, project managers maintain a project plan for sake of simplicity, guys. Okay, so let's come here and let's say, here is his project plan. What is he doing? Well, he's saying, I got a file 1 and let's put this here. It's split into block A. Block A is saved on this data node 1, data node 2, data node 3. What is this one, Srujan? He is just making a note of it. He's not saving it. He's just maintaining the metadata of which file, where it is split, where it is distributed and replicated. You understand that, Srujan? Cool. As simple as that, Srujan. Okay, so if you understood that, and is name node, and second one is MapReduce. Okay, when we come back to MapReduce, what we are telling is this is like a department. This is your software department. This is your hardware department in your IT company. These guys are responsible for the processing part of it. These guys are responsible for the storage part of it. Internally, we have what is called Task Tracker and Data Node. What is it? These are like Windows services, if you're familiar with the Windows operating system. In Windows, as you open Word, Excel, and things like that, behind the scenes, there is a Windows service which is running for each program, guys. Okay, what are they? They are background process. So really, what happens in the world of Hadoop is these are the background process or related to Hadoop that they are running. These background process are communicating to their masters. They communicate. They report to their masters and say, "Hey, buddy, I got one block. That's my block." It sends a status report periodically. That is why these guys are called workers or slaves. They report, and these guys are getting that report. When let's say this block got deleted, select this one, this block got deleted, this guy will go back and say, "Hey, I don't have any blocks now." What will this guy do? He will update his project plan. It's like saying one of the as a worker, you're employee, you're updating your project manager. Once you update your project manager is going ahead and updating his project plan. That's how you can think of it, guys. Okay, good. Okay, so here is IT Company 2.0. There are some changes. We'll talk in more detail what these changes are when we cover Yarn. Yarn I will cover after a few days, guys. Okay, but there are a bunch of changes, and the changes are, here are the changes in short. Your hardware department, nothing changed, but in your software department, there are some changes. These are the changes we'll talk later. For now, I'm just giving you an idea about it, guys. Okay, everybody okay with that, guys? Great, thank you, guys. Okay, so now let's see what is the typical workflow. What's the typical workflow, and what is the typical work that you do in Hadoop? Okay, step one, we load the data. Once we load the data, we've been, let me see, I think I cleared that. Okay, we load the data means we will take some, huge amounts of data. The big data is what we have been talking about. We'll go ahead and load it into Hadoop cluster. How? We will use a simple Linux command. We'll talk about that maybe tomorrow, guys. Okay, and then once we load the data, what do we need to do? We need to analyze it. How do we analyze it? Using MapReduce. That's where the software department comes to your rescue. This is where the hardware department comes to our rescue, and they will help us in loading it. Or in other words, internally, it is Hadoop which is taking care of. Internally, the Hadoop framework is taking care of. Its hardware department is taking care of storing. Then its software department is taking care of analyzing, guys. Okay, and then what do we do after we analyze? We get some results. What do we do with the results? We go ahead and store them. Where do we store? Again, they're stored on HDFS. Cool. So let's come here. They're again stored on HDFS, guys. Okay. Once they're stored on HDFS, that's when the third-party applications come in. It could be a visualization application such as Tableau, ClickView, or a .NET application or a Java application, and they will read this processed data, whatever we analyzed. Okay, they will read that and they will try to use them in their recommendations and things like that. Now, conceptually, that is what it is, guys. But let's actually take a look at this scenario. We'll understand that. So what is happening here? How many times did our customers type the word refund into emails sent to customer service? What is this? It seems one of the universities in US, what they have done is they have taken the 10 to 15 years of Outlook data, the emails and all the data, entire archive data set of that they have received in the past 10 to 15 years. If you put that together, that will probably be in multiple terabytes. What do? The first step, they load that into HDFS. Second, they started analyzing that entire 10 to 15 years of data. What were they analyzing? Well, they looked at every email where the word refund was appearing. Okay, they started analyzing. They first detected which are the emails where the refund appears. Then they will write some advanced, some kind of algorithms or machine learning things, or, other kind of SQL, Hive, Pig, and scripts like that. What did they find? It seems they found out their objective was, they wanted to understand why students who are applying for the universities are applying for a refund. And what did they do? Well, it seems they found out most of the students were applying for refund after applying, because at the time of admissions when they were calling, their calls were not being returned, or in other words, there was no response. Okay, that was the root cause of why they were moving on to other universities. Obviously, if our questions are not answered, we may think the university is not interested in us, and we try to move on, guys. Okay, so what is that? That's an example of an insight. That is what they understood. So what did the university do after that? Well, it seems after that, every time when the admissions time is coming up, they went ahead and made more service representatives available at the time of admissions. Why? They don't have to lose the students. Okay, so it's it might sound simple, guys, but what is happening? They took their entire 10 to 15 years of data set and they went ahead and analyzed that one is one point. And now, guys, the insight they got is they understood that, hey, students' questions are not being answered is one insight. What is that insight? In what way is that helpful? Well, it is not an insight which is useful only one time. For the rest of their life, they can go ahead and use that insight is, one thing to note. And guys, okay, what do we have? Instead of the word refund, imagine you come up with some more meaningful word, meaningful term. Do similar kind of analysis. What do you get? We get more insights. What do we get? What do we do out of those insights? We make more useful decisions. Everybody see what I'm trying to convey here, guys? That is only one word. But imagine you come up with some meaningful terms, meaningful words. How many insights can we get? How much of the good decisions will that help in? Gentlemen, ladies, is that making sense, guys? Cool. Okay, in other words, again, that is that is what everybody is doing. What is happening here? This is unstructured data. People never thought, I will take a 10-year or a 15-year data set and I will do some analytics on that. That's what the world of big data is opening up. That's what the world of Hadoop is doing it. Now, they're not only taking your 10 to 15 years of data set of Outlook, but they're looking at every kind of data set they have. Why? That's because Hadoop is making it possible, guys. Okay, and gentlemen, ladies, another important thing is it is a university which started this one. Okay, for sake of simplicity, let's say if it is a third-party company, an IT company or something like that, who have a product and they also can take their emails and they will analyze it in a similar way. Do you think it is possible? It is okay. It makes sense, guys. Can this concept be used by other companies also to search for the word called refund? Cool. How about other colleges, guys? Is it only for one university, or is it for every colleges can also use? You think so? Y or N? Can you type in? Cool. How about schools? And do you think it's only useful in one country or all the countries, guys? Type in a Y if you think it's useful all over the world. Gentlemen, ladies, that is Hadoop. The solutions, the use cases that we are solving, right? What happens is as we solve one use case, they become globally applicable. We're seeing that kind of use cases when be globally applied. They can be used for solving in other companies and things like that, in other domains also. That is one of the very good advantages of Hadoop. That's why everybody is getting into Hadoop and they want to start doing something with it, guys, okay? Everybody okay, guys? Can I move on to the next slide? Cool, and let's come here. So that is the previous slide, Srijan, in case you are asking for that one. I just saw your message. Cool. Okay, Srijan. Oops, sorry, that's one. Okay, so let's come here, guys. Let's see what we have here. We are going in a little bit detail. We are saying, hey, we have a cluster. A cluster is a group of computers. We have what is called a master. Master is name node. That guy is called a hardware manager. A worker is called a slave, and a slave is called a data node. This guy is a hardware employee. He reports to the hardware manager. This guy is only responsible for the storage. We'll not go into resource manager, node manager, and HBase components now. We'll come back to these things in the later sessions, guys. Okay, just bear with me. Everybody okay, guys? Cool. Another important point is the data node stores the blocks. What is a block? Block is a split of the file, a part of the file. And they're actually getting saved in the workers. They are not getting saved in the masters. What are masters doing? They're just monitoring. They're just tracking which worker has which block. Cool, guys, gentlemen, ladies, one more time. Could you type in a Y, please, if you're okay with this slide? Cool. Okay, so let's go a little bit of theory. When you have a few minutes, just go ahead and have a quick look at this one, guys. Okay, so what is a file system? Well, what we are more specifically talking about is Hadoop. It's a distributed file system. It's a group of computers, but they act like they're a single computer. Cool. What's happening? Data is split into chunks or blocks, then they're saved, then they're replicated, SDR. Cool, guys? And what is namespace? Namespace is the project plan of the hardware manager. What is hardware manager doing? The name node? Name node is just maintaining, is monitoring which file is saved where it is distributed, where it is replicated, SDR information of each file. What is that? Well, if you take a group of files, you take their metadata, that is also called metadata, guys, okay? That metadata is same thing as namespace. It is also referred as namespace. What is it? A file where it is saved. A list of files where they are saved, where they're distributed and replicated. That is what this namespace is about, guys, okay? Then metadata. What is metadata? Metadata is your actual data. Metadata and namespace could be used in a slightly interchangeable manner, guys, okay? At a high level, we call it as namespace. At a low level, we're calling it as metadata. It is nothing but a file. Who is the user who created? What is the group he belongs to? What are the permissions? Do you have read, write, and execute? And what time it was created? What is the size of it, and things like that is the metadata. Cool. Storage. Storage in a file system is on a physical server or network attached storage, and these devices will persist data which is chunked. Generally, each data node is one physical machine, and data node is your worker. That is where the blocks are stored. Okay, the devices will persist data that which is chunked by blocks. So in other words, that's what we mean, guys. Okay. Apart from that, HDFS, all the file system tools have tools to perform operations such as administrative operations, such as troubleshooting and fixing. So there will be admins, Hadoop admins, Linux admins, and things like that. They will be using their own set of tools to make sure the data is not corrupted. And if it is corrupted, they will do the troubleshooting and things like that, guys. Okay, these are all the things that go on in a HDFS. Everybody okay with this slide, guys? Kind of, you don't have to by heart this, or you don't have to keep the entire word to word in your mind, but just have a high level idea of the things which go on here. Gentlemen, ladies, could one of you type in a Y? Great. Let's move on. Oops. Come here. Okay, a bit more about what we just discussed. Let's come here. Cool. HDFS, the hardware department. Okay, and it consists of a cluster, a group of computers, group of machines, often referred to as cluster. Okay, there are two main components: the hardware manager, the hardware employee. The manager is called the master because he monitors it, and he manages the data in other nodes. And what else we have? The name node. The manager will contain the project plan, which is the namespace and the metadata. Don't worry about journaling and block map. Block map is nothing but which block is situated where and things like that. And one more thing, guys. Okay, the block map. What is block map? Which file where it is split, distributed, and replicated is an in-memory map. In other words, imagine this manager. What is he doing? Well, he maintains a project plan. It's a hard copy. It's an Excel spreadsheet saved in a file. But what is he doing? Imagine whatever is there in that project plan, he's also remembering it. He's kind of keeps it in his memory. Why? At any point of time, if somebody requests one file, he will be able to respond very quickly. Okay, let me also put it like this, guys. Okay, imagine a hardware manager. Imagine a manager, he has a group of employees. A project plan is, he's saying, okay, a particular task is assigned to one developer. He's maintaining a spreadsheet, which is a hard copy of it. Apart from that, he's also remembering everything. Why? At any point of time, if the clients come and ask, where is this file or what is the status of my task? What he does is he does not open the Excel spreadsheet. He just says it out of his memory so that he can be quick and fast. That's what we mean by in memory. Whatever the manager is maintaining, monitoring, right? He's maintaining in the RAM. That is what that means. What is it? Well, which are the data nodes? What are their IP addresses? What are the blocks that they have? And things like that. What are their permissions and things like that? That is namespace and metadata. What are data nodes? The workers. These are hardware employees. They store the data. The actual data is getting stored there and is responsible. They are responsible for storing the data. Okay, guys? Everybody okay with this slide, guys? Cool. And gentlemen, okay. Block map, a list of blocks. List of blocks, your SDR information. Syed, Irfan. Okay, buddy. Cool. Okay, so a bit more, again, kind of repetition, but I will just go ahead and have you a quick review, guys. The name node and data node are daemon process. They are like the Windows services, guys, okay? Behind the scenes, they are nothing but a process, a background Linux process. And by default, only one name node is used. In other words, in our IT company, we maintain only one hardware manager. For now, that is what you think. It creates a single point of failure. What does that mean? If that manager leaves our organization, he takes a project plan with him. In other words, we are at a loss of project plan. And what does the project plan have? Well, which developer, which task is assigned, what they're working on, and things like that. Now, without that project plan, the IT company does not function, or IT company is in kind of chaos. They don't know where it is. In other words, if this server goes down, wherever this background process is running, your entire cluster, all the computers are kind of lost. They don't know whom to report, whom to come back and report. So what do? They all kind of stop. For sake of simplicity, think of it like that, guys, okay? Later, HA, high availability, is introduced to mitigate this. That we will talk in when I cover YARN. So bear with me on that, guys, okay? Data never resides or passes through name node. The master never saves any data, is one point, is what it is, guys, okay? Your big data only resides on the workers, which is slaves. That's what that is. Data nodes are referred as slaves or workers. They are daemons. Daemon means a background process, okay? They're constantly communicating with their master. They're constantly updating their manager and saying, here is my status report, buddy, okay? That's what we employees do on a weekly basis, guys, okay? That is true, Srijan. The name node keeps the entire namespace in the RAM, so that if any clients request what is the status or where is my file, it can reply it very quickly. And that is the reason why the RAM is so high, 64 GB RAM, 96 GB RAM, and things like that. The default chunk size is 128 MB, but we can configure it. Different companies maintain different standards, guys, okay? We can also have multiple name nodes, but that we'll discuss in YARN, when we discuss YARN, Pratyusha. For now, think of it as we have only one name node. Cool? The default replication is 3. That means every time a block is saved, 2 additional copies are maintained. And that's what that means. Data nodes communicate with other data nodes, okay? So the workers will be communicating with each other, is what that means, guys, okay? Everybody okay with this slide, guys? Cool. Okay, let's see where we are. Okay, all right, gentlemen, ladies, do we have replication? No, not right now. The short answer, Advait, for now, think of it as no. Later we'll discuss again the replication of name node in YARN. Cool, so just give me a little bit of time. So gentlemen, what we'll do is today we'll go ahead and wrap it up here, guys. Tomorrow also I will be on Fridays, especially, I will be having the session from 8:30 to 9:20 or 9:30, guys, because I have a meeting going on between 8 and 8:30. So I need to be available in that meeting. So that happens only on Fridays, guys. Monday to Friday, I'm available at 8 p.m. my time. So I just want you guys to keep that in mind. We'll regroup at 8:30 tomorrow. Everybody okay with that, guys? Cool. Okay. So for today, allow me to sign off, guys, and let me see. Srijan has, you're going to a reasonable place. I'm happy with the level of details you give us very much. Hey, thank you, buddy. I appreciate that. You really make my day, and very few people are like you, buddy. You focus. You're saying good as good. So I really appreciate that, and hopefully that is helping others also. That's a good spirit you're showing in sharing the positiveness, and I really appreciate it, Srijan. So you hang in there, and Again, thank you for that, buddy. I hope others are also finding it the same, guys, hopefully. So if you have negative or any other kind of feedback, just come back and let me know in a friendly way. I'll appreciate that. For now, what we'll do is we'll continue 1 hour a day, and slowly I'll increase it to 1.5 hours a day, Srijan. That is my plan, okay? So just bear with me on that. Cool? Okay, great. Okay, guys. So for today, I will wrap up here. But what I also want to convey to you guys is just go ahead and complete your formalities so that I can share the deck and I can also share the virtual machine, and you can also start practicing, guys. By now, you would have got a feel of how the things are going and what how we will be going ahead and things like that. I think you can be assured that I'll keep you. You're in good hands, so you don't have to worry about that. So please try to complete your formalities so that you can get your hands onto the deck and the presentation deck and the VM, guys. Okay. So that's a final word. And Srinivas, go ahead, buddy. You want me to unmute you? Okay. It's Srinivas. Okay. Only easy questions, Srinivas. No tough questions, buddy. Just kidding.
Yeah. My question is regarding the block size. We have, for example, 64, 128, whatever it was. Does that depends on the input file size? That was my first question.
Does it depend on the file size? No, it depends on the.
For example, if you're taking a file which is of 500 GB or 1 TB, and the block size to be increased.
Yeah. No, that is actually decided by the administrators. Administrators decide whether they want to keep it as 64 MB or 128 MB. Not the file or anything else. They decide. How do they decide? There's a particular way how they design a cluster based on the data that they're looking, based on the budget they have, how much volume they're looking, velocity they're looking, what is the variety of the data. All these factors they consider at the time of designing a cluster, and they'll say, hey, we're going to go with 128 MB. It's not really rocket science, it's simple only, but they can choose anything.
Because why I ask this question is because, as we said, this big data means everything is being TBs, terabytes, right? And also, I'm seeing the replication factor is of 3, which means that from one data node, the copy need to be transmitted to the other data node. So the size is only some 60 or 128 MB, but the size of the whole file is of 1 TB or something.
Good question.
So there should be so much of data between transferring between the.
But remember,
and which may.
Very good. Okay, but remember, we are not maintaining 100 Ferrari cars. We are maintaining only 1 or 2 Ferrari cars, and rest of them are taxis. In other words, we are maintaining a lot of cheap servers. So even if your data is getting replicated, our cost is not growing exponentially. It is growing linearly, is what you can.
What about the traffic network? With the data transfer, a lot of data transferring between the nodes, which may result in slowness or something.
There are many ways to optimize them, Srinivas. Okay, we can look at it from a processing standpoint. You maintain your reasonable connectivity. You maintain a private network for your Hadoop cluster.
I may ask in this way, like, will the cluster size? Okay, can you give me idea how many data nodes may be generally in the production environment or whatever?
10 to 100 to 1,000.
Okay, it may be around 100 to 1,000.
Absolutely, yeah. You can have them.
Okay. So because I'm thinking big size of data and then it need to be replicated. So replication means data transfer need to be happen.
True.
So much of data, so much of transfer data. So
but that happens only one time. You don't do that every day. Only at the time of loading, you're dealing with your 100 terabytes is getting replicated to 300 terabytes is first point. Second point is that's happening the first time. The second time onwards, you don't move the data around. It is a code which you move around, which is just like a single dot. It's exponentially small compared to the size of the data. And in spite of that, we will still run into performance issues. So what do we do? Well, that's slightly deeper. That comes somewhere in the 7th or 8th class. We are still in the first class. We just completed LKG and UKG, and we are now in the first class.
Let me stop my questions. Okay.
No problem, buddy. But hopefully you're understanding what I'm saying.
Yeah.
Is Srinivas. Cool.
Yeah. Thank you so much. Thanks a lot. Yeah.
Thank you, buddy. Appreciate that, Srinivas. Cool. Thank you, Srinivas. All right, gentlemen, ladies, let's call it day. You guys take care. Have a good one, and we'll catch up tomorrow, guys. Okay. And thank you again, and bye for now.